Okay, so question 2M4 from Statistical Rethinking, second edition. I'll let you read the question, but the basic premise is that we have three different playing cards. Okay, so we have 1, 2, 3 different playing cards. Okay, and one of these has a white side and a white side, two white sides. One of them has a white side and a black side, and the other one has two black sides. Okay. Now, one of us, me, I put these into a bag, I take one out, I put it on the table, so you only see one of the sides, okay? And the side that you see is black. And so now I am asking you to decide, or to estimate, calculate, what is the probability that this other side is also black? In other words, what is the probability that we've drawn the black card here? Okay. So if you're like me, when I first look at this, I say, okay, well, I've seen a black card or a black face, and there's two cards that have a black face. Therefore, I'm going to guess, or my intuitive answer is that the probability that the other side is also black is 1/2, right? Because there's two cards, again, with black sides, and I've seen a black side, so it has to be one of those two cards, okay? And that reasoning process is very intuitive, but it's also incorrect. And I don't know that if I see a problem like this that uses the same principles in the real world, that I will immediately intuit that. And so, but what I can do is recognize that whenever I have evidence and I have a hypothesis, in this case the hypothesis being that one side is black, I can plug all of the numbers in, or all of the estimates in, to Bayes' theorem. And so that's how we're actually going to solve this one. Okay, so let's go through and apply Bayes' theorem here. Okay, so with Bayes' theorem, I'm going to change that a little bit. Okay, so we are trying to solve for the hypothesis of having drawn the black card given the evidence that we have seen black. Okay, now when we go to, so this will end up being our posterior right here, right? This is our posterior probability that we're trying to solve for. So let's start plugging stuff into Bayes' theorem, or building out Bayes' theorem here. So the first thing that we have is our likelihood, okay, and the likelihood is just simply inverting the posterior. So the evidence of black on the assumption that a particular hypothesis is true, in this case that we've drawn the black card, okay? So this is the likelihood here. And then we're going to multiply that by the prior. And so the prior is just simply the prior of the particular hypothesis that we are curious about. Okay, in this case, the probability that we've drawn the black card. Okay, so this is the prior. And then we divide all of that by the marginal, which is just the probability of the evidence. Okay, so the probability of having drawn black. Okay, so, and again, this is called the marginal here. Okay, so let's come up with some appropriate values for each of these terms. Okay, so let's start then with the, get some more, can I get more of that on here? Yeah, good enough. Okay, so let's start with the likelihood. What is the what is the probability of having drawn or having seen a black face given that the card we drew was black? Well, of course, that has to be 100%, right? If the card we've drawn is black, then we're always going to see a black face up. So that is just 100%. Okay. Next is the prior. What is our prior probability assigned to the black card? Okay, so there are 3 cards, and black card is just one of them. So this is 1/3. Okay. In just as a quick aside, with our faulty reasoning process up here, I think this is where the mistake gets made. We might be in our very quick intuitive reasoning, we might think that the prior should be 1/2. Why? Because we saw a black, and so I know that there's only 2 cards that have a black side, and so I want to. So well, anyway, but that's against the spirit of what the prior is. Remember, the prior is supposed to be set before we see any of the evidence, before we see any observations. And so without having seen the black side face up, well then, we know that the prior has to be 1/3. It's one of the 3 cards that we can draw. Okay, and then finally, what is the evidence of drawing or of seeing a black face? Well, there's 3 cards, and each of those cards has 2 sides, and 1, 2, 3 of those sides is black. So we have 3 of 6, or we have 1/2. Okay, and so as we go to calculate this, so now we have that this all equals 1 times 1/3, oops, that's a half, times 1/3 times 1/2. Okay. And when you solve this, so we have 1/3 over 1/2. Invert all of that, so now we have 1/3 over 2 over 1, and we get 2/3 as the posterior distribution.